Hello, everyone. If I can ask you all to take your seats and settle in, we've got a lot of exciting programming for you today. First of all, I want to thank everyone for coming in person. It's really great to see so many people, and I hope I continue to see smiling faces today. We have a lot of exciting things to talk about. First of all, let me introduce myself. My name's Amanda Odell. Up here, up front with me, I have Matt Fowler. Matt, give him a little wave. We are the co-directors of this year's IgniteX Climate Tech Accelerator program. Before we get started, I want to go ahead and start with a quick safety moment. Always important to be aware of your exits in case of an emergency. If something were to happen during this presentation, please exit straight out the back. There's 2 sets of stairwells. Both of those will take you to grade. And we have some people here from out of town. For those of you, please review your emergency egress routes from your hotel rooms in case of an emergency. All right, with the fun stuff out of the way, let's talk Climate Tech Accelerator. So the Climate Tech Accelerator, I'll start with a little bit of history on the IgniteX program in general and then a little more deeply onto this year's program. This is the 3rd year that BV is hosting the IgniteX program. The program was founded in 2019 with the Clean Tech Accelerator, continued in 2020 with the COVID-19 Response Accelerator. And since its inception, the program has fielded over 500 applications. We have given $1 million in grants and in-kind services, and we have made 32 investments or partnerships with startup companies that we worked with. So for this year's program, absolutely, yes, thank you. And for this year's program, we have selected 8 startups among the 90 different applicants that represented a whole slew of climate technologies and within a bunch of different industries. And today we'll see a wide variety of those represented. And you will hear from our startups how they have worked with Black & Veatch and their Black & Veatch champion over the last 12 weeks and beyond as we continue to work with them for hopefully many years into the future. So with that, I am going to pass the mic off to Black & Veatch's CEO, Steve Edwards.
Well, welcome everybody. Look, I'm really excited to be here today to just kind of get us kicked off a bit. And from the Black & Veatch perspective, we started on these Ignite sessions some years ago as part of our growth accelerator. And that was really to fuel our growth, but also to make a difference around the globe. And our mission has been building a world of difference for some years. And we know to do that, we have got to be more innovative and we've got to push the edges on infrastructure because that's one of the slowest things to evolve. If you look back over history, been a lot of change, but it's typically been pretty slow. So our IgniteX program, our growth accelerator, has really been steered at accelerating the pace of change that Black & Veatch can deliver in our solutions to our clients around the globe. And we do that by internal ideas, but also reaching out to a partnering network. And everybody knows, all the great ideas obviously are not inside Black & Veatch. We've got amazing talent. A lot of them are sitting here in the room today that are way smarter than me. They're brilliant at what they do. But to really expand that and build on it, we've got to establish a really strong partner network. And as we developed the Growth Accelerator, we knew we needed to reach into the startup community to get the best ideas out there that we're ready to take to market and help move those to the market, help either validate them, prove them out, or provide a means for them to engage with our clients or other ways in the industry to put them to work and begin to scale them up. When we do that, we absorb and we learn a lot. We learn a tremendous amount from the startups that we work with that helps us be better at what we do. And this year's cohort, as I look through the types of technologies that we're looking at that embrace thoughts around the circular economy, decarbonization, resiliency, and sustainability, it really gets my blood pumping. I mean, I can't imagine a better portfolio of companies for us to be working with and the ideas that are out there. They're really, really exciting, and I'm looking forward to you hearing more about them as we proceed with the program here. But from my perspective, we've worked with, this will make it about 30-some companies, and this group that we're working with now is really exciting. When you think about recycling clothing into raw materials, you think about the technologies we're going to hear about today to store energy or create hydrogen and green ways at efficiencies that heretofore haven't been available. Those kinds of things are what's necessary to move the world towards zero carbon. And those of you here today can hear about ways that that can happen. It can become real. This isn't make-believe. It's not something that can't happen. These are technologies that can change the world and change the climate. So with that, I'm going to hand it off to Matt. You coming up next? All right, thanks.
All right, so let's get started with our first cohort. I'm going to bring up Jonathan Christiani to introduce Next Hydrogen, our first company. So give it up for Jonathan.
Thank you, Matt. Good afternoon, everybody. My name's Jonathan Christiani. I have the extreme pleasure of serving as Black & Veatch's Bioenergy and Hydrogen Technology Manager. And I'm very excited to talk about our relationship with Next Hydrogen. Now, as many of you know, we have a long history in the hydrogen industry. We have a lot of relationships that we've been building, strategic partnerships, but what makes Next Hydrogen so special is a combination of a novel technology and a good position in the marketplace to work with someone like Black & Veatch to bring this promising technology to the market. Now, part of what we're doing here in the first phase under IgniteX is looking specifically at balance of plant design, integration. That way they can focus on their core technology, the electrolyzer itself, and helping them do some of the application analysis that's needed to bring the technology to market. So what this all will culminate in is the submission of a grant application that we have one-pagers if you care to take one and learn more about the program. Over the long term, we'll be working on more major design of plants, scaling the technology, and bringing the combined talents to a commercial market. And with that, it's my pleasure to introduce Milan Yang, who is a process engineering lead from Next Hydrogen.
Thanks, Jonathan. Hi, everyone. My name is Milan, and I'm here on behalf of Next Hydrogen. We use our technology, our systems, to drive down the cost of producing clean hydrogen from renewable power because it is one of the crucial parts of a solution towards global decarbonization, which is definitely a goal that we all hold very dear to our hearts. So I'm very excited to be here today and showcase some of the work that we've been doing with Black & Veatch as a part of the IgniteX project. Next Hydrogen is an OEM and turnkey solution provider for water electrolyzers and electrolyzer systems based out of Canada. This is actually a photo of our facilities that we just opened this year. Now, hydrogen electrolysis, the goal is to produce clean hydrogen with no GHG emissions using renewable power and water. And that, at our core, is what we do. We are technology developers. We design and fabricate our own electrolyzer stacks and balance of plant systems, and we also do ongoing product development and system optimization to bring down the cost of that product. But we're also systems service providers, because we operate and we service our sites that are installed currently. We train hydrogen techs, and we also participate in standards development because we know that there are concerns and questions around operating safely with hydrogen. Lastly, we're integrators. We focus on, from the source of the power all the way through to the end user, the requirements of each unique application, because we want to deliver a system whether it's part of our core technology or incorporating third-party components that works for the application. Because an application that has a well-fit solution is what's going to keep the operating costs low for the long term. And we're all familiar with how versatile hydrogen is. You can use it everywhere. But through our market analysis with Black & Veatch, we continue to identify a couple of key industries that we think are going to lead that shift. Predominantly, we see a need that resides in large-scale industry. So industries like ammonia synthesis and petrochemical refining, these are industries with existing need for hydrogen. And currently, almost all of it is supplied by generation through carbon-based fuels like steam methane reforming. And there's also newer industries, I should say, like in steelmaking, calcination, and all of these industries, when you look at clean hydrogen, that'll enable them to step away from finite fossil fuels. And electrolysis as a solution can help them diversify their assets, make them more robust for the future, and maybe allow them to leverage some green premiums on their product. The second leading industry is going to be heavy-duty material handling and transportation. This is where battery electrification is starting to see some challenges, and applications in long-haul trucking and in high-torque applications are really going to see the benefit of hydrogen, whether that's through fuel cells or even direct combustion. And electrolysis in these industries is also a good match because it enables distributed generation, which is a good fit for mobility applications. And so Next Hydrogen has designed our product to start addressing some of the challenges that these industries are facing in adopting electrolysis. The illustration in the middle there, that is our stack assembly. And we are currently working with an alkaline technology, which enables us to use commercially proven materials, establishing robust supply chains, and also keeping costs down. However, we've made some internal changes. You can see that it's very different from the conventional design. We've brought the gas separation into the stack. The repeatability of the cell is going to really allow us to optimize manufacturability, again, keeping those costs down. And also, the internal flow paths allow us to achieve higher current densities than the conventional design, which means more hydrogen produced per unit area of active space. And so all of that is going to keep the footprint small. It's going to facilitate integration into existing industries and also for mobility distribution. And finally, that same design change is what gives us the ability to respond dynamically to intermittent renewables. So we can load follow the intermittent and variable signals from things like solar and wind, and being able to couple that, being able to directly couple electrolysis with renewable power is going to open up a lot of opportunities. It's going to make it more flexible for industries if you couple that with strategic storage, if they need continuous operation, but the renewables are intermittent. And it's also going to enable mobility applications if they need on-demand hydrogen. And our current objective now is scaling up. There are a lot of opportunities here to benefit from the economies of scale, and we're looking at it from two fronts. So the first would be, how can we scale up a unit stack? But we're also looking at how can we optimize a system for multi-stack installations. And so with Black & Veatch, we've pulled together a representative 20 megawatt system, which is a good size to consider integrating into something like an existing ammonia process. And this is something that could potentially supply not all, but part of an existing demand, because this isn't a change that's going to be 100% switch over overnight. Doing a phased development is going to really de-risk that shift, and that's kind of how we see these large industries adopting it. But even at 20 megawatts, there's a lot of opportunities to optimize the supporting systems, and those are lessons learned that can be transferred as these systems get bigger. But at a certain point, you also have to look at the unit stack. And our product development right now is focused on taking our stack and turning it into a 9 megawatt single stack. And that product development project is what we're hoping to have funded by the Sustainable Development Grant. So in collaboration with Black & Veatch, we are actually searching for a third consortium partner. And that is a partner with a need for hydrogen, an application that's suitable, a site to host the demo installation, but most importantly, a partner with the same vision for green hydrogen on a massive scale. Thank you.
All right, thanks, Milan. Up next, I would like to welcome Samuel Bretz, who will be introducing our next company, ReJoule.
Hello. Thank you for that. My name's Samuel Bretz. I'm a control system engineer within Black & Veatch's Battery Energy Storage System Group. I've been working with ReJoule for the past few months to provide information about industry standard practices for battery energy installation, how their solution might integrate within it, and identifying the impact and the stakeholders involved. ReJoule is designing and developing a tool and service to pretty much enable what I believe to be one of the next significant material marketplaces. And with that, I introduce Stephen Chung, CEO of ReJoule.
All right, thank you, Samuel. Hi, everyone. I'm Stephen Chung, CEO of ReJoule. We're building technology to enable a circular battery economy. So the battery industry is going through some funky times right now. The cost to build a battery pack has actually gone up for the first time in a decade due to the cost of lithium, cobalt, nickel, and all these other materials rising sharply in recent months. The CEO of Rivian, RJ Scaringe, he recently said that this looming battery supply issue is going to make the chip shortage look like a small appetizer. Yikes. If anyone knows battery supply, it's this guy, or maybe the owner of Twitter. In California, my home state, we have aggressive plans to decarbonize the grid by pairing utility-scale storage with renewables like solar and wind. But we can't find enough batteries to fulfill all that demand, and so some of these projects are getting delayed into next year or even 2024. So this battery supply issue is real. But what if I told you there's another source of batteries, one that's actually growing, one you don't have to mine or import materials to access, and all we have to do is look in our garages? A McKinsey study estimates that by 2030, in 8 short years, there can potentially be more usable battery capacity coming out of electric vehicles than the grid demand for energy storage. That's up to 220 gigawatt hours of energy storage from electric vehicles. And that's a huge number, by the way. For reference, in 2021, there was 28 gigawatt hours of utility scale storage installed globally. So on the one hand, you have a shortage, and on the other hand, you have a surplus. So let's put the two together. There can be an amazing opportunity here to repurpose used electric vehicle batteries for stationary storage applications. But there is a caveat. All that battery is not usable unless we have widespread testing first. You see, electric vehicle batteries, they do degrade. We know that. Drivers have different driving habits, different charging habits. People have different commutes. There are going to be electric vehicles in different climates, and temperature is going to have an effect on degradation. And this is all known, and therefore we do need testing. But the problem is today's state-of-the-art testing for battery packs it costs too much and it takes too long, up to 10 hours per vehicle. You're essentially charging and discharging each of these battery packs. And that's not scalable when we're talking about millions of these electric vehicles per year. So because it's difficult to test, most of the time right now, we end up not testing. And if we don't test, then we don't know the usable capacity or the power of these batteries. And if we don't know, then these batteries become useless. I've personally seen megawatt hours of used electric vehicle batteries just being stockpiled in warehouses. And if we don't act now to build up that testing capacity, we're going to have a lot more of these warehouses. And we may be sitting on gigawatt hours of useless batteries per year. So how do we avoid this outcome? Well, first, we need a way to quickly and accurately test these batteries. And then we want to be able to take that data and be able to forecast future used battery supply. And that's some of the technology that we're building at ReJoule. We're building a device that can plug into a vehicle's charging port, take a pack level measurement, and then be able to predict the state of health of that battery with less than 2% error in less than 5 minutes. So compare that to the 10 hours before. That's orders of magnitude improvement in test time. By planting these devices at service garages and dealerships across the nation, we can help EV technicians diagnose these batteries, and then we can help identify when will this battery need to be replaced. We can also identify if that battery does need to be replaced, should it be at the module level or should it be at the pack level? And when we do replace that battery, where is it going to go next? We're going to monetize this technology through what we call a grading as a service model, or GAS. So yes, we will be selling gas to the electric vehicle industry. And the customers will be paying on a per EV model, per month basis. And that actually aligns our revenue model with the value that we're adding to these customers. Our underlying intellectual property is based on a test called electrochemical impedance spectroscopy, or EIS. Now, we didn't invent EIS, but we do have a patent pending position on some of the hardware that's able to perform EIS on high voltage battery packs, and also be able to take that measurement and make sense of it and interpret it in interesting ways. We've also validated this technology already on multiple types of batteries, from cylindrical cells and prismatic modules, and also different chemistries, from nickel NMC chemistries, as well as a lot of different LFP automotive batteries. Okay, so now that we have this data, we're going to put it up into the cloud. And by planting these devices at dealerships across the nation and eventually across the world, we'll be able to build what I like to call a virtual battery warehouse. We're essentially inventorying these used electric vehicle batteries when they're still in the vehicle. And with this, we can make a decision like, we know that in the next quarter, there's going to be 20 megawatt hours of fourth generation Nissan Leaf batteries between 78% SOH to 82% SOH. And we know there's a buyer in Charlotte that wants to build a PV plus storage site in the coming months. And we can help facilitate that transaction. And doing this will help us create a more reliable and a more predictable used battery supply. And that's going to help everybody. And we're already on our way to do some of this stuff. We have some Second Life battery projects going on in California, funded by the California Energy Commission, where we've tested over a megawatt hour of used electric vehicle batteries from trucks, material handling equipment, and buses. We plan to have 2 sites operational by the end of this year. We have a project with an OEM, a major OEM, to get our technology working for one of their flagship electric vehicles. And we're going to focus on specifically getting our technology working through the CCS charging protocol. So that's a very exciting project coming up. We're also rolling out a pilot scale virtual battery inventory warehouse with an upcoming Department of Energy grant that's going to be starting in June. And then also next month, I'll be traveling across the pond. We have our first commercial customer in Europe, where we are deploying our fast battery grading units on some lower voltage battery modules. We're also fundraising soon, a seed round. So any investors out there, please come find me after if you're interested. My email will also be on one of the later slides. So what we're trying to do is build a circular battery economy, and that ends with putting batteries into the ground. And that's where we don't have a lot of expertise. And a lot of Black & Veatch's support during this IgniteX program has been helping us understand what are some of the risks involved with that end step. So one of the key things that the Black & Veatch folks have helped us do is we're looking at risk reduction. We're doing a PDRI for some of our existing second life battery projects. And we want to use this PDRI as a blueprint for future projects as well. We're exploring integration into existing battery energy storage BMSs and microgrids, and looking at everything from the electrical, mechanical, software, and data integration with battery energy storage systems, and how we can integrate our state of health analyzing device into that. This isn't completely finalized, but we're looking to demonstrate our state of health, our fast state of health technology in an R&D battery microgrid laboratory with Black & Veatch in the coming months. And in the future, we're looking at potentially some Black & Veatch and ReJoule stationary battery test offerings. So having a lot of interesting conversations around there, looking at very, very interesting business models that we wouldn't have ever thought of without participating in this IgniteX program. Oh, and during this program, I also participated in a webinar with Anurag from ElectricFish, who will be presenting later, so that was really cool. It was a webinar for an SAE Detroit event, where we talked about fast charging and battery degradation. So overall, it's been an amazing experience. And as we try to build this circular battery ecosystem, Black & Veatch has played a critical role in helping us chart that path forward. Thank you, everybody.
Thanks, Stephen. All right, so for our next company, I'd like to bring up Kevin Currants to introduce 12. Let's give it up for Kevin.
Thank you, Matt. Good afternoon, everyone. I'm Kevin Currants. I'm a project director at Black & Veatch in our chemical and industrial products segment. I've also had the opportunity over the last year to participate in Black & Veatch's decarbonization team, where I supported various carbon capture and carbon utilization projects. Again, I'm up here today to introduce 12. Unfortunately, due to prior commitments, representatives from 12 were unable to be here with us today. So they have shared a video that we're going to show here in a few minutes. I will point out that the video itself is available on Twitter in a full 8-minute version. We're going to show a bit of an excerpt of it today. So I'd ask you to check your social media programs to look at that video and learn a bit more about 12. 12 is a carbon transformation company. They take carbon dioxide, water, and electricity and convert it into many of the products and materials that we use on a daily basis. Those products would normally come from fossil fuels or from petrochemicals. Over the last 12 weeks or so, we've worked closely with the 12 team in looking at several different areas. First was really the project definition aspects, as 12 goes from laboratory scale to pilot facility and then ultimately to demonstration and industry scale facilities. It's important to understand the information that is necessary for an engineering and construction company to assist them in building those facilities and achieving their goals. The other aspect that we've worked with them closely on is reviewing their product and feed treating requirements. So looking at the configuration and the technologies that are adjacent to their technology that they're working on, but are certainly necessary for development of those facilities that I mentioned. And then lastly, we've been working with them to identify and come up with schemes to have low-cost renewable energy that's necessary for their facility. So the CO2 that they're using can come from any source, so we can extract it from the air that they're currently breathing, or they can extract it from flue gas from a facility that's going through a combustion process, or any source of CO2 is applicable. So with that, I'm going to, here in a moment, allow you to watch this video clip. After the video, my colleague Jonathan Christiani will return to the stage and talk a little bit more about his thoughts on the 12 technology and how that might fit in with Black & Veatch's portfolio. So if you play the video.
I mean, when most people think of a chemical company, they think of like a large refinery, these billion-dollar assets that are at high temperature and high pressure. I never envisioned myself working at a company like that, and I'm not in a lot of ways. What 12 does is that we make CO2 electrolyzers. In fact, we make PEM-based CO2 electrolyzers, and those electrolyzers do CO2 electroreduction. And we have transition metal catalysts that are engineered to convert carbon dioxide into currently 2 new molecules that we're focused on, but ideally any molecule that you can make from carbon, hydrogen, or oxygen could be made in this process.
We kind of have this dual benefit of our technology where you can both address emissions that need to be either taken out of the atmosphere or generally prevented from going into the atmosphere, and also be able to displace fossil fuels in existing supply chains where we don't have better alternatives to date. We can actually take the emissions from those really difficult to abate sectors and transform the carbon dioxide into products that we actually need to live.
Our technology works like industrial photosynthesis. In the same way that a plant takes CO2, water, and renewable energy and turns it into oxygen and useful carbon-based products, our process takes CO2, water, and electricity, and we break apart the CO2 and water and use catalysts to recombine the elements to make new, more useful products that are currently made from petrochemicals.
Behind both of those processes are catalysts. You don't actually see the catalyst in a tree, and you can't really see our catalysts with the naked eye. And so in a lot of ways, we had to build the tree and then build all the infrastructure around it to be able to support this industrial carbon cycle.
Hello again, folks. So many thanks to the 12 team for their brief video, and to Kevin for the nice introduction. As mentioned, I work across the renewable chemicals, the renewable feedstock space, renewable fuels. I have the background in bioenergy, so certainly appreciate the aspects of 12's technology that are almost an homage to bio-based solutions and biomass. But wanted to highlight the applicability across our new energies portfolio, what we're calling. So many of us who have been champions on behalf of the IgniteX cohort serve across that portfolio. We're working on carbon capture, we're working on hydrogen, clean fuels, and most importantly, we're working in a field referred to as power to products, power to X for short. So the promise that 12's technology holds in kind of bringing together many of these different pieces and cutting across application sets is something that was really important to us to be a component of our cohort this year. So we thank them a lot, and although they couldn't be here today, we did want to make sure that we properly represented the technology. Thank you.
All right, up next, we'll be hearing from Carbon Upcycling, and to introduce them, we have their BV champion, Albert Prifty.
Can you hear me now? Okay. Hello, everyone, and good afternoon. I'm glad to see so many people here on the stage and be able to hear our stories. You know, the story of IgniteX this year is about climate tech, and climate tech is one solution towards achieving climate change and adaptation. And that's where I think Black & Veatch as a human infrastructure company looks to make a difference. And as we work in that space, we learn more, and we try to learn, and by partnering with the right innovators and scientists out there, they're looking to scale their technologies. Achieving climate change comes through decarbonization and new energy solutions. But that doesn't necessarily need to come with a sacrifice. Most of the world thinks that we got to make these huge sacrifices to do that. Some will take place, but in some cases we have to look at it as an opportunity. And this is what carbon upcycling is doing, is looking at how to achieve CO2 removal, which it's related to decarbonization, but also how to turn that into a valuable product that is not only going to make our lives better and less energy consuming in the future, but also help our projects of the future be carbon free. So, here on stage, as a champion for carbon upcycling, I've had the pleasure to work with Peter and his team, and the help that I received from my team and everyone involved to really learn how to help them scale and look at the demonstration projects and scaling up the commercialization opportunities that exist. One last thing I want to say, in my role as a new energy solutions portfolio manager, I look at CCUS, and that stands for carbon capture, utilization, and sequestration. And carbon upcycling plays a key role in that utilization value chain, and it's definitely going to make something happen here in the future or in the near future that is not only going to help the industry, but also help Black & Veatch. Our DNA is construction, and what they do is they valorize construction products by providing enhancement to waste products as well. And I think Peter is going to cover that, and he does a great job at it. So with that said, thank you, Peter, and the carbon upcycling team that couldn't make it. And also I want to thank all of our team members on our IgniteX team for the carbon upcycling. They did a great job, and we look forward to continue conversations past the program. We're looking to work together towards an MOU and executing projects in the future together. So that's exciting, and with that, I'm going to pass it to Peter Zhao, who is the process lead for carbon upcycling and on my book, #1 scientist. Thank you.
Thank you. Thank you, Albert, for the warm introduction. Good evening. I like to capture the story of why climate change is so important from a building material context. We've been rapidly driving urbanization, been driving humanity to new heights, and this is one of the causes behind climate change, one of the biggest problems of the 21st century. Today, CO2 emissions from the construction materials sector accounts for about 8% of global GHG emissions. So that's roughly equivalent to what India as a country emits as a whole. So it's significant. And that is because we cannot get enough of cement. It's a carbon-intensive material from both a mass perspective, how we process it, as well as an energy perspective, the amount of power, heat that's required to make a kilogram of cement. And today I wanted to share a little bit of a story about how we're making that transformation. So a common practice in the industry today to address this problem is using materials known as supplementary cementitious materials. So these are materials that are not cement, but they exhibit similar properties, and you could use them to substitute out the carbon-intensive cement clinkers to make a product, or to make your concrete formulas. Now the problem with that is that, one, you can't use too much of it because it sacrifices on performance. And two, there's not enough of it in the world because of our transition into cleaner energy, and this is how it's highlighted. One of the traditional SEM materials, known as fly ash, is a byproduct of coal combustions. Coal plants are going away. Second, iron and steel slag is another one of those materials. We're electrifying the steel industry. And so I'm here to talk about how we're creating the next generation of SEMs. And this is our elegant technology. So we take CO2 and we combine it with otherwise materials that's been trapped in landfill, materials that's been in landfill for a while, no one's used it, it cannot be used in large quantities, and we have our patented reactor technology that combines them together, introduces it into the existing supply chain without modifying any of the ways that existing concrete and cement companies works with it. And in turn, we're creating a high-performance cement formula with some of our partners and capturing CO2 and building greener and stronger products and building materials. As a result of all of this, our materials has been CSA and ASTM certified. It's approved. And as you can see, we could use actually a range of different products. We could use flue gas directly or CO2 from captured carbon plants or from DAC units. We could use a range of feedstocks, some of which are local that couldn't be used because you couldn't substitute it in replacement for cement, enabling local supply chains, helping to drive unit economics and local building materials. And we're also working with 4 of the world's top 15 cement and concrete producers like LafargeHolcim, Cemex, to continue to scale and drive forward some of this technology. What's really interesting is we also wanted to highlight our technology also helps them to expand their plant capacity. This additive material now enables our customers to make more money, deliver better products, and products are greener. And this is why they love us. In terms of material performance, stronger concrete, stronger buildings, no changes to how the construction workers work with the materials. Better performance all around, at times it's even cheaper, and we can utilize local feedstocks. So it's great. And we've been really excited to be here today to share with you a little bit of our progress. Over the past couple of days, we worked with the decommissioning solution manager, Mark, and identifying how could we help the existing customer base at Black & Veatch, specifically in the coal industry, to help them decarbonize, to help them build assets from what's now ash ponds, materials that they couldn't use, and transform them into high-performance products. And we're so close to the market. These are the things that we really want independent feedback on. The PDRI, so we can identify our gaps and risks. The team back in Calgary is working extremely hard to cover some of those gaps, and we're really excited to work with Black & Veatch continuously to fill the gaps, to get independent technical feedback. We've scaled the technology over the past 5 years by 60 million times, and for the next one, I think we'll need your support. And finally, looking at how do we extend this relationship to something much longer term in establishing relations with your customers and ours all across the world. So this is the team. 3 years ago, we were a team of 6, but now we have strong backing behind us, strategic investors from around the world, strategic customers, and we're really excited to add Black & Veatch onto this portfolio as well. And this is the team that ultimately today starts the genesis of how we're going to capture and utilize over 77 million metric tons of CO2 over the next couple of years. And we're really excited to work together to dive into the technical details. In terms of next steps, as Albert highlighted, we're capturing a lot of the technical details, working on the MOUs, and we're really excited to scale. Our target to deployment is Q4 later this year to help our customers in the United States, Canada, all around the world to decarbonize. It's ready today, and we can't wait to see it in action. As a conclusion, I want to just wrap up and highlight to you our mission as a company. We want it to be the most impactful carbon tech company in the world. And we're doing that by showing what we could do with a small team. We're deploying products. Up to today, we have over 1,400 metric tons of products deployed in Western Canada, and there's more in the portfolio to come by. But I've also wanted to highlight that we're also working in different sectors, such as in petrochemicals and plastics, where we're creating the same types of products, high-performance plastics, low carbon footprint. And so I really want to encourage you to come up and chat with me, and we could figure out how we could break this, because I haven't been able to. So we can show that green is also better. Thank you.
Thank you, Peter. Coming up next, I'd like to introduce Mr. Frank Jacob, where he will bring up our next company, Revterra.
Thank you for that, Matt. Good afternoon, everyone. We're halfway through this exciting day. I'm Frank Jacob. I'm the Director for Advanced Energy Storage Solutions at Black & Veatch. And I'm really energized to introduce you to the only kinetic energy storage solution presenting in the IgniteX Showcase today. I've been involved with startup companies for over 25 years. Super scientists, excellent engineers, brilliant business minds, many of whom often stumble over seemingly small steps: permitting, siting, one-line drawings, harmonics. Just a few of the ways that Black & Veatch works with our startup companies in the cohort. And to tell you more, I'm going to introduce one of those super scientists, the CEO of Revterra, Ben Jodat.
Good afternoon, everyone. Thank you again to Black & Veatch and the IgniteX team for having us. So the motivation for what we're working on is the upcoming and currently in progress of electrification of transportation. The number of electric vehicles that we see on the road today is really just the tip of the iceberg in terms of what we're going to see over the coming decades. All those electric vehicles need to charge somewhere. And so to support this electrification of transportation, we're going to have to deploy millions of electric vehicle charging stations every single year. And those are not just low power charging stations. People want an experience like filling up their gas tank. So when we think about the time, the power that it would take to charge a typical 60 kilowatt hour car battery in 10 minutes, that's about 350 kilowatts. Now, if we have 8 of those 350 kilowatt chargers powered at the same time, that's as much power as a 1 million square foot office space consumes. So it's a very non-trivial amount of power, and that's going onto our aging electric grid. The process of installing these electric vehicle charging stations is also fairly complex and time-consuming. So you have to do things like wait for the utility company to give you permitting. You have to dig trenches to bring in new distribution lines. You have to pay for and install bulky transformers. And when an electric vehicle comes to charge at one of these high-power charging stations, it draws a relatively short duration but very high-power surge from the grid. So what we can do to avoid this surge of power, reduce the demand charges, substantially reduce the CapEx involved in building these charging stations, is buffer the power between the grid and the electric vehicle using an accumulator. So this energy storage module would accumulate energy at low power over a longer period of time. And when an electric vehicle comes in, it would discharge at high power. So the grid never sees that surge of power that the electric vehicle draws. The challenge with an energy storage system in this type of application is that it has to be able to withstand many cycles per day. So at least 5 and trending towards 20 over the coming years. And all these cycles place a strain on the system. So our solution is a modular energy storage system that stores energy in a low-cost, off-the-shelf steel alloy that's fully recycled. So basically, it takes electricity from the grid, uses a motor to spin it up, and it sits on a proprietary magnetic bearing that we've developed that reduces the energy losses by 20 times compared to conventional kinetic energy storage systems. Now, critically important to mention is that our system can undergo 40,000 full depth of discharge cycles over the lifespan. And again, this comes back to the high cycle count in this particular application. So if you compare to a traditional electrochemical battery, over a 22-year lifespan of our system, you'd have to replace that at least 8 times. If you're doing 5 cycles per day, if you're doing 20, you can see how that would be further exaggerated. So how does this actually translate into a cost savings? Well, the cycle-adjusted cost for our system compared to a lithium-ion battery per kilowatt is less than 1/10 that of the comparably sized lithium-ion battery. And that's because we can offer it at a kind of comparable upfront capex, but there's a lot more cycles. The power is also important. So the power to energy ratio with our system is 4. They're decoupled, so we can increase the power while keeping the energy storage content the same. And this is just a comparison with traditional batteries where the energy and power are coupled together. With our system, we can increase the power by 4 times, deliver that energy 4 times more quickly, charge the car faster. High-power electric vehicle charging is the first application that we want to pursue for the reasons I mentioned before, but there's a lot of interesting adjacent applications and markets that we are also excited about. On the low-power side, there's peak shifting and energy arbitrage, which we think we can address with a 2nd or 3rd generation version of our system, which would be scaled up substantially. But on the other side is grid inertia. So because our system is a physical rotating system that could spin at grid synchronous frequencies, it can actually provide physical inertia to the grid the same way that gas turbines do today. With high penetration of renewables, we lose those gas turbines, we lose the inertia that they provide to the grid, but we can actually replace that physical inertia, and we're thinking about the possibility of providing that as an ancillary service from the electric vehicle charging stations. In terms of what we've already built, we've built a prototype Kinetic battery in our facility in Houston. This is a subscale prototype, but it de-risks the technology, proves out all the core aspects and concepts, including the proprietary magnetic bearing. A little bit about our team. So we have 2 full-time people, myself and our CFO, Patrick. We have a couple of part-time mechanical engineers, as well as an advisory board, including technical and business development expertise. And our excellent partners, including Black & Veatch, NextEra, Greentown Labs, and others. A little bit about our timeline, where we're at, and what we've accomplished. We raised a seed round of funding in 2019 from angel investors in Houston. We received an SBI, Phase 1 SBIR grant from the National Science Foundation in 2020. So that combined with the seed round allowed us to build up the prototype, de-risk the technology. We also have some customer traction in the form of LOIs with a couple of utility companies, as well as with a high-power EV charging network developer. And over the past few months, we've been able to participate in the Black & Veatch IgniteX program, which has allowed us to leverage the mechanical engineering, civil engineering, electrical engineering expertise that they have, and do things like develop single-line electrical diagram for our planned pilot project with the high-power EV charging network developer, and we look forward to continuing collaboration with Black & Veatch. We're raising a Series A at the moment to fund the development of our commercial scale modules. We've already secured a lead investor for this round, and we're looking to close in the near future. So if you're interested in that, please reach out. And we're aiming to complete our pilot test next year. So with that, this is my contact information, and thank you for your attention.
Thanks, Ben. I really love that Frank used the word energized. I definitely feel energized by seeing all these amazing solutions, both personally and as a representative of Black & Veatch. And that's certainly not going to stop with our next company that we're going to spotlight. So I'm happy to welcome Jackie Karyosha to introduce Circ.
Thanks, Amanda. As she mentioned, my name is Jackie Karyosha, and I'm a process engineer and solutions manager for Black & Veatch. During my time here, I've had the opportunity to work on a variety of decarbonization projects, including carbon capture and biofuels. So when the IgniteX team invited me to work with Circ, I immediately said yes, because it allowed me to pair my polymer background with my design experience in the decarbonization space. What I find so interesting about Circ is that they're using their technology to help solve the plastic pollution problem. What you might find surprising is that the waste they're tackling is textiles. About 60% of our clothing today includes polyester, which means it's a vital piece in the recycling solution. With that teaser, I'm going to let Luke Henning tell you more about what Circ is doing. While he couldn't be here today, I'm sure you'll find his message just as riveting. Please roll the video.
Hello, everyone, and thank you for this opportunity to present today. My name is Luke Henning, and I'm the Chief Business Development Officer at Circ. Circ is a pioneer in the field of textile-to-textile recycling. We closed a Series A in 2019, led by Patagonia's Tinshed Ventures and supported by Marubeni Corporation, one of the large Japanese trading houses, as well as sustainable investment funds, Alante Capital and Card Sound Capital. These were later joined by Circulate Capital and by 1890. We will soon be announcing the close of our Series B round, and these funds will be used towards scaling and commercialization of our technology. But we're particularly proud of our partners who are supporting our goal that everyone, everywhere, should have access to clothes made from circular recycled materials. Let's talk about recycling clothing and about how much of an issue this is. What most people don't realize is just how much material is used to make clothing. You know, when we think about this, the most common material used is plastics. You use 2.5 times as much PET for textiles as you do for the beverage industry. There's 60 million tons a year of plastic. Now, if we go on to the next fiber there, we get onto cotton. And now cotton, the challenge there is it is a pretty thirsty crop. We use very little of the weight of the crop, and that same land could be used to grow food. When we get away from cotton and we think about how do we get that same natural hand feel, the same hydrophilic properties, we get to the man-made cellulosic fibers. This is your lyocell, your viscose, your rayons. Challenge is we use about 200 million trees a year to produce these fibers. And there are all sorts of challenges with this. When you combine that with the fact that we only really wear our clothes 7 times before we discard them on average, you get to a situation where, according to the UN, up to 10% of greenhouse gas emissions a year come from textiles and footwear. Now, if we take the US as an example, only 6% of all material that goes to landfill is recycled. And that's generous because it's actually about 1% that's recycled textiles to textiles. The rest is downcycled into blankets, shoddy blankets, into the moving blankets that you see, into dog bedding, into acoustic paneling. There are about 13 million tons or more that are sent directly to incineration or landfill in the US every year. That's about $50 billion worth of resale value that's just lost to the industry. And why is this? Well, the primary reason is that blended textiles cannot be recycled with current technology. The moment you bind mixed chemicals together, you can no longer recycle. And everyone wants this recycling. You know, we're seeing a lot of regulation come through, like the EU with their zero textiles to landfill by 2025. Italy has already started a curbside recycling process where they're collecting all the textiles to assess what they have. You've got recycled content laws coming into place. California, which by itself would be the 5th largest economy in the world, is now insisting on recycled content in its bottles, 50% by 2030. When you take that into account, you realize that this is a competing demand for all that plastic. A lot of companies and countries are pursuing carbon neutral goals. And then consumers are also driving everyone to become more sustainable. And we see this playing out in the fashion industry with all of the very substantial commitments that companies are making to be more sustainable. I could put down a list here as long as my arm, but let's take 2, for example. We've got H&M and Adidas. Now with Adidas, they are talking about 100% recycled polyester by 2024. How are they going to do this? Well, for this, they've got to use bottle plastic. But as I said, there's not enough bottles out there to recycle into this. And so this is causing a massive demand supply gap, which is driving up prices. And also bottles to textiles to landfill is not as good as bottles to bottles. And Coke and Pepsi want their bottles back. This is where we come in. With our patented solution, we can take waste polycotton. We can replace oil and trees used for textile production with raw materials that we source from waste clothing. And we source this from aggregators in waste management, from charities, from brands that have excess inventory, from the supply chain that has a very large amount of excess waste. For every shirt in your closet, there's about a shirt of waste along the supply chain. And because we can accept multicolor, post-consumer or post-industrial polycotton waste, we have a substantially lower feedstock cost than the rest of the industry. When you put this into the facilities which we are looking to build with joint venture partners and with vertical integration, we can have a lower processing cost than the current industry. This leads to higher margins, and we can compete with virgin on cost. Now, what does the solution look like in reality? If you look at the screen there, you will see an 80-20 polyester to cotton blended t-shirt. We wouldn't normally put a whole t-shirt in our process, but this creates a useful showcase of what we can do. The polyester is dissolved out into the liquid and broken down into its basic chemicals. This is PTA and ethylene glycol. These can be recombined to make new polyester. The residual cotton, we process to a dissolving cellulose. It's a high purity cellulose that can be made back into the man-made cellulosic fibers. So we can use that cotton cellulose to replace trees for lyocell, for viscose, for rayon. We could take that polyester, break it down, rebuild it into new polyester, and the dyes and finishing chemistry can then be responsibly captured and disposed of. Now, why were we so keen to work with Black & Veatch as part of this program? Well, this was very well suited for us. We're looking to scale and to build that first facility. And we didn't really have the engineering muscles in-house yet. So being able to assess a prospective EPC through a program like this was really invaluable. We also got to meet and know the team, so we knew if we were compatible in terms of working together. We need a partner who can help us with Facility 1 and beyond. Now, important with any accelerator is to work out how you get the maximum value from the program. For us, this was very challenging with this program because we had significant resource constraints on our side because we were in the middle of a fundraise. Thankfully, this is coming to a close. And I must say, Black & Veatch was very good in terms of working with us on being flexible in terms of timing and in terms of duration of the work we were working with them on. What was also very useful for us with the work we did do with Black & Veatch so far is that they've been able to give us a third-party look at all the assumptions we had been using in modeling our first facility, and also giving us their view as an outsider on what areas we should be focusing on in the near term to accelerate that progress. One of the things we did with them specifically was the PDRI assessment, and that we felt was very helpful. I think it is important to stress with any accelerator and with anything like this is see it as building a foundation for future work and future projects, because what we are doing now has the potential to be a much longer term partnership. This partnership does not end at the end of the accelerator. So thank you very much for all of your time. I just want to part with one thing, and that is we at Circ really believe that we can wear the same molecules for life. We have all the clothes we need to make all the clothes we'll ever need.
Yeah, it's unfortunate Circ couldn't be here today, but I'm very excited to continue building the relationship with them and continuing our partnership. Coming up next, we'd like to bring up Ryan Pletka to introduce Nitricity.
Thank you, Matt. It's a pleasure to see everybody here today. I'm Ryan Pletka. I'm one of the innovation leads for the company. It's been a pleasure to work with Nitricity. If there's a silver lining to climate change, I think what it's really done is it's spurred sort of an across all industries look at how we can do things differently. And in some cases, we can not only address climate change, but think of new solutions that are better than we've ever done before. I think you've seen that today. And I believe Nitricity is just another example of a new elegant solution, this time in the fertilizer space. What Josh and his team have done is figured out a way to make fertilizer with 3 simple ingredients: water, air, and electricity, renewable electricity such as solar. So I'm really excited to have President and CTO of Nitricity, Josh, come up here and tell you all about it.
All right, thanks, Ryan. It's my pleasure to be here today. Thanks for joining us, and I've been thrilled to be part of the IgniteX program. I'm Josh McEnany, the president and CTO and one of the co-founders of Nitricity, and this is Nitricity. So Nitricity is making renewable fertilizers from air, water, and electricity. Our mission is to fix nitrogen in a better way. We're going to electrify and distribute the production of fertilizer such that we can lower the greenhouse gas emissions associated with fertilizer and increase global food equity. The greenhouse gas emissions associated with fertilizer right now are about 6 to 7% of all global GHG emissions. Nitricity is following 3 megatrends, that there's a growing need for fertilizer. As the human population increases, so does our need for nitrogen fertilizer. There's soaring fertilizer prices right now. There's a couple of different crises going on that are influencing this, but in general, nitrogen fertilizers are very variable in prices because they're tied to natural gas and super centralized. And then the renewable energy revolution gives us a source of really cheap electrons, which are helping some of the companies you've seen here today, as well as Nitricity, put these electrons to work making products. Speaking of that fertilizer crisis, the fertilizer's been in the news a lot lately. We're seeing very high emissions from fertilizer, of course. The tariffs associated with fertilizers are also in the news, and then that there's the crisis in Ukraine, as well as global supply chain issues with COVID have been causing this 4x increase in fertilizer prices. All right, there's problems today in the production, distribution, and application of nitrogen fertilizer. In the production, fertilizer is made as ammonia in the Haber-Bosch process in these super centralized facilities. There's a couple hundred of them around the world, and then you distribute to billions of acres of farmland in pretty complex, some safety concerns, and a lot of different chemical transformations to make all the fertilizers that are used today. So in that distribution, or rather in the production, there's about 1 to 2% of global GHG emissions caused by using natural gas or coal as the feedstock for making the ammonia. In the distribution, there's additional GHG emissions, but you have that expensive supply chain that costs more to farmers as they're trying to pay for these fertilizer needs and feed the planet. And finally, in the application, I really want to highlight that about 5 to 6% of global GHG emissions come from these N2O field emissions, and that is a result of using the wrong type of fertilizer, over-applying that fertilizer, and potentially using it at the wrong rates, ultimately leading to an enormous amount of global emissions. And we've found a solution that we think is going to help knock down those N2O emissions quite a bit. And that solution is to first produce nitrogen fertilizer using a plasma-based process on air, water, and renewable electricity. Our process mimics a natural process for making fertilizer, which is thunderstorms. So as lightning strikes down, it fixes nitrogen, and that fixed nitrogen is captured in rain, and the rain lands on fields, growing the grass greener in the next couple days. Our process containerizes that lightning. This lightning in a bottle goes into this shipping container, and our second fertilizer pilot in Fresno County is using 50 kilowatts of solar to make a bunch of fertilizer, which goes out to 25 to 75 acres of farmland. So our process is more distributed, more climate friendly, and then when you finally are putting it on these fields, the nitrate-based fertilizers are very amenable to fertigation, so you can fix the timing of fertilizer, as well as nitrates have a much lower emissions factor than ammonium-based fertilizers, as long as the field is reasonably dry or not over-flooded, so not like rice paddies, but other types of fields. So far, we've been working with some major partners to scale up our process. We've worked on a research farm in Fresno, California, 3 kilowatt solar array. As the sun came up, we'd make a bunch of fertilizer. As the sun went down, it would stop making fertilizer, and we can send it out to the fields. We grew some processing tomatoes and broccoli as a result of that collaboration. And then after a good over a year of operating here, we upgraded that system to a 50 kilowatt solar array that I talked about in a partnership with Terra Nova Ranch, who's led by the president of California's Board of Food and Ag. And we're also working with IFDC to verify our N2O field emissions, which again is a real target of the company to try to knock those down. Next, we're going to be working with Black & Veatch. We're really excited to be part of this program and working on the next scale up, which is to multi-megawatt fertilizer projects. They've been helping us with set the foundation and apply to some grants and funding sources to start that process, as well as helping us source some sites where that project should go. Yara has written us a letter of support. Yara is one of the largest producers of nitrates in the world, and they're interested in potentially selling some of our fertilizer through their sales channels as a climate smart option for them. And we're raising a $20 million Series A right now. We're pretty far along in that process, but happy to talk with anybody who's interested after this talk. Ultimately, we want the lowest cost, lowest emissions fertilizers in an electrified future. So we do a lot of comparison with green Haber-Bosch and green ammonia processes and trying to get our costs below those, or at least competitive with them. And we do see a future where we can do that. We're hitting record efficiencies now, and those efficiencies translate to reasonably cheap fertilizer prices. So we want a low cost and a stable cost, so we don't have to deal with these crises and natural gas highly fluctuating the cost of fertilizer for farmers. And finally, we want a very low emissions fertilizer, such that these N2O field emissions and the emissions associated with fertilizer production are way knocked down. Ultimately, we want to fix the way we fix nitrogen. I'm Josh McEnany with Nitricity, and thank you for listening.
Thank you, Josh. And that brings us to our 8th and final presentation. I'd like to welcome Rick Azer to introduce ElectricFish.
Thank you, Amanda. So, been working with ElectricFish for the last couple of months. It's been a really amazing opportunity for us to work closely with a startup company to help them look at commercialization and scaling. We heard earlier there's millions of charging stations left to be deployed over the next decade. There's a solution here that Anurag's going to speak of a certain subset of those that really benefit from low voltage connections still being able to provide high power charging in specific instances. I think this is going to be a crucial component of the overall solution and of the charging ecosystem. So really looking forward to supporting what ElectricFish is doing and growing along with them as they commercialize and scale. So Anurag, please let us know what's going on.
Thanks, Rick. Could you imagine a world where each and all of us have 100% renewable energy powering not just our homes and businesses, but also our transport? It's going to take a lot from the centralized architecture, which we have right now, to completely retrofit into a more decentralized one in which we locally generate and store energy and have a distributed, decentralized network of storage and EV charging, as Revterra has talked a lot about as well. I'm Anurag, the CEO of ElectricFish. I lead a diverse team of individuals coming from very diverse backgrounds. I have spent time in industry working for EVs and batteries and charging systems. Vince has worked for selling stuff in regulatory space. He knows how to work in the regulated industries. Nelio has built systems which have actually went to space. And Fala currently goes to Stanford. She's a data professional, figuring out how to build systems which can mass decarbonize our current oil and gas industry. We are also recognized as the Silver Award and at the Edison Awards in the critical infrastructure category. And we're very proud of being part of ecosystems like LACY, Scale for Climate Tech, and Texas Equinor program. But let me start with the problem which we started with solving. We are putting more and more renewables to the electricity grid, which is aging. We have to retrofit and put a lot of public fast chargers, something which the grid was never designed to do. It was designed to generate energy using fossils and power homes as compared to EVs, which draw energy up to hundreds of homes for a very short extent. This is making the installation of these chargers very slow and very time intensive, which draws down to users having a poor charging experience in which there are no chargers in the vicinity where they live at or experience very high waiting times at public fast charging stations. Whoever could solve this problem would take a massive market of this $262 billion for providing resilience and DC fast charging, and we think there are 3 keys to it. First, figuring out to make deployments which can make quick ROI as compared to what's standard in the industry that is a decade. Second, make sure that we can quickly integrate with the grid-constrained sites like cities where you could not get permits super fast. And finally, provide a user experience which is seamless, probably like gasoline. And we think we have the solution to do that. The 350 square is essentially a microgrid, which connects with a single-phase or split-phase connection, drawing up to 100, 150 amps at 240 volts or 208 volts, and actually can feed power back to the grid, equivalent to powering 40 homes for 6 hours. But still drawing that power can still provide gasoline-like charging, delivering up to 140 miles of range in just 7 minutes of charging, almost at par with gasoline. And our patent is on being able to containerize everything into a box and dropping it at a site without any site preparation, which makes it really scalable solution. But we didn't want to be just a hardware company, so we built tools around it. The core score tool on the bottom, Community Resilience Score, is a data tool. It specifically uses data sets like where exactly the grid is weak, where is EV demand going to show up, what is the probability of an outage based on historical data, and also some demographic data sets because we want to have an equitable impact of our solution to choose where to deploy these units. Then we put our hardware there, and we have a software engine running on top, which actively makes decision on how to allocate the energy which we have for the future vehicles which are going to come or for a possible outage which is going to happen. And we use that data, feed it back to core score, and it keeps growing our competitive edge. The intelligent site selection tool, which we have, is a novel alphanumeric spatial AI, which keeps learning from the data which we're generating, and our hardware is redeployable because it can just be dropped. And it's future-ready because EVs for the next 5 years are going to keep charging at this pace. And finally, our optimization engine cuts the ROI of this intensive hardware from up to more than 7 years to just 2 to 3 years, and just optimizes multiple value streams. And this is where Black & Veatch comes into play. We wanted to prove it out that is our infrastructure quickly scalable or not? Can we actually deploy these units in just weeks, not years, as compared to competition? We needed to prove out, can we just avoid any trenching? Do we need any upgrades? Can we really prove it out that it's a zero-hassle deployment for our partners? And our partners are our go-to-market as convenience stores, gas stations, and also auto dealerships. These are the 2 markets which we're looking at. And from our user research, we found out that first, we generally have just low voltage connections available, that is 208, 240 volts. The city and AHJ, that is authorities with jurisdiction like fire codes, fire marshals, the permitting was taking much longer because there was not a standardized process around it. And finally, it was very difficult to navigate the leasing agreements because there are just too many stakeholders involved. A gas station is operated by somebody, owned by somebody else, and there is an oil and gas major putting the gas there. So that is what we tried to tackle at this 12-week program at IgniteX with Black & Veatch. In February, we had a site visit from a permitting specialist, and we devised an innovative way to split the permitting process into two different parts, in which we first get a single-phase connection with a tiny pedestal installed at site, which is pretty much off the shelf, takes a week to do, and then we classify our boxes as technically a temporary installation. We still have to prove that out, but we can drop that unit, and it just takes a few weeks to deploy. In March, we got help to structure our legal contracts to standardize it. So just learning from Black & Veatch's experience working with all the charging companies, how the contracts were structured. So we got help there and also structured contracts for our partners. And finally, in April, we started doing our safety reviews because we're doing our installations, and we are planning for the next few months as well. Between this time, we also collaborated with ReJoule. Stephen just mentioned us a few minutes ago. We talked with SA Detroit, with most automakers present in the audience, to prove it out that you need to build fast charging technology in your vehicles, do short charging, fast charging, and so what is the importance of used batteries. What's happening in the next weeks? Okay. As we have got 2 pilots coming in, one with DTE, that is electrical utility from Detroit. We already got that paid pilot approved from them. And second, we have a pilot with an automaker, which is not announced yet, but we are making an installation at their dealership. And what we're going to prove it out is first the pedestal method, if it's actually working, get the AHJ process standardized, and also creating this data on how bankable is our solution so that we can tap into different project financing capital. We don't have $1 trillion to build thousands of these units. We have to prove it out and get project financing for our units because we want to build a network. So what's happening by 2025? We want to put 1 gigawatt hour of storage all across the US, and 3 different states is the goal. That means 3,000 installations, helping critical services keep their lights on. We want to make sure that we are also capturing equity, that is, making deployments in underinvested and disadvantaged communities. That's very central to the vision of the company. And we will cut 500,000 tons of CO2 by making the grid and the vehicles greener. There are 4 SDGs, which we closely work with, but SDG 9 and 11 are what's most dear to us and most relevant. So finally, I'll close it out by saying that we are really trying to reinvent the electricity grid, bringing that energy, which we all deserve, continuous access to 100% renewable energy. And there is an opportunity for you to be a part of our journey as well. We are currently fundraising. My email is right there. That ends with a .co, not .com. Thank you all.
All right, as we bring today's program to a close, I just want to say thank you all for attending in person and all of you who attended virtually. Being a director or co-director of this program for the past year, it's been really exciting to see how Black & Veatch has really partnered with innovators and had searched for innovators across the globe to really help us facilitate our goals and bringing change forward in the climate tech space. So today, and this whole cohort would not have been possible without a few key individuals. First off, I'd like to thank our IgniteX champions, who really professionals at Black & Veatch that stepped into this role to help be a conduit to the cohort back into the broader company to help drive their objectives forward over the past several months. Also, the innovation team at Black & Veatch is very strong and has been a great support of this program. Ryan Pletka, Rick Azer, Ilya Tabak, Zach Olson, and Mark Vranikar really helped guide us as we were building this cohort this year. And then today, this event wouldn't be possible at all without my co-director, Amanda Odell, who really drove us to the finish line here over the past month or two. So shout out to Amanda. So if any of you guys would like to connect with our innovation team or any of the companies, please feel free to reach out to myself, Ryan Pletka, or any of the Accelerator team, and you can do that through the Growth Accelerator email on the screen. We'll also be sending out the slide deck and a recording of today's presentation for you to share with anybody that's interested. So at this point, we have a networking reception out back. thank you guys for joining us today, and we're excited to continue innovating here in the future. Thanks.